There is an online system. This online system is used to make the data accessible much faster. Okay, it's not only for reading purpose, guys. Okay, the screens are used by the users to inquire some information, to update some information as well. Okay, some of the project business will run to online only, guys. Let me tell you one more time. In yesterday's class, guys, we are talking about the online system, and you need to remember that the only reason why online systems are used is to work with the data in a very quick way. Batch process will take all the data and process at once in a nightly process or a weekly process or a monthly process. But an online system, guys, the user or the customer, okay, we have two people. User will be there, customer will be there. Both of them want to use the data which is in the mainframe system, and they cannot go into technical points to get the data. Like they don't know how to create a data set, they doesn't know how to run a SQL query, so they don't know the technical part. So as an IT solution providers, what we do is we provide a screen to the users. We provide a front-end system for the users and ask them to give a minimum information. Okay, ask them to give a minimum known information and get the data from the system without knowing any technical things. So this online systems, as I told you, it would be a user front-end system where only CICS will be the story, or it would be a customer friend system where there will be multiple other applications also involved. So as part of our training, guys, we are learning the mainframe CICS part, mainframe user front-end system, because this is the 80% system. This is the 80% system where we'll be having a CICS screen which will be used by the users. Okay, users will be interacting with the CICS screens, or I would say BMS screens. The actual word is BMS, basic mapping support. Okay, actual screen is the BMS screen. This will be used, and whenever the user provides any input or anything, your CICS will call the program, our COBOL CICS program here, and this will go and talk to the data. It could be a file, it could be a table, it could be a temporary queue, and then it will interact back with the data results, whatever it came to it. Whatever the data results came, it will be sent back. So to understand this whole picture, okay, as a technical person, if you want to understand the whole picture, we split into two parts. We told first we will write a programs to interact with the screen. Then what we'll do, along with this interaction, we'll also write the right side part to interact with the data as well. So do different steps we have divided here. And the first step here is to screen communication. That's what I tell you, screen communication. Now, when you have a screen, guys, you have a screen communications. As per your application, guys, as per applications, we will have, okay, we will have almost like a 20 screens, I would say, which are very much active. Okay, there will be around 20 screens which are very much active, and there might be another 10 to 20 guys which are like less used. So your project, okay, in your application, there will be a lot of screens, guys, lot of screens will be there, but not all of them you need to learn perfectly. Okay, some of the screens are very rarely used, like every day, every minute you will be using. Some of the screens are completely useless. Nobody uses it. Sometimes even you forget there is a screen also. So I would like to tell you how exactly you need to design a screen. I would like to tell you how you need to interact with the screens. So these screens, guys, these screens will be sometimes a menu based screen only. It contains only menu information. It doesn't do any data processing. No data processing at all. Sometimes you'll be having data processing screens will be there. In this, there will be a screen which is only for inquiry, which will be only for inquiry screen. It is like you give an input, yes or no. Maybe sometimes you don't need to give any input also. So if you give an input, system will show you the data, show the data. There is a second screen which will be used for add, only add. Okay, I would say only add, only update as well. Okay, only add, only update as well. And there will be a common screen, guys, sometimes. Okay, most times what they do is they create one screen and they can allow you, okay, they can allow you to add, they can allow you to update, they can allow you to inquire as well. Okay, by just changing couple of options. Okay, by changing couple of options, you can use the same screen for update and everything as well. Okay, so anything, just consider there are two categories. One is the menu based screens will be there, which users will be using them and navigating to certain screens for their particular data reasons. So the other one is the data processing screens, which contains either inquiry purpose, only updating purpose, or combinations also. Very easy, guys, very easy. You can just imagine them. When I show you my real-time project now, I'll show you these kind of screens as well, so that you get an idea how the project screens are there. Okay, but first thing first, to design the screen, guys. Okay, to design the screen, we need to start learning. Okay, we need to start learning BMS coding. Okay, BMS language or BMS coding. Using COBOL language or using JSL language, guys, we cannot design a screen, guys, right? Using COBOL language, we can process the data. Using the JSL language, I can execute a COBOL program. But both are not used for designing the screen, guys. If I want to design a screen, we need to use something else. So the screen designing for CICS is BMS coding. Okay, BMS as your basic mapping support. Using this code, we will write the actual design part. So in this BMS coding, guys, there will be three components. Okay, let me tell you in a simple way. There are three components. One we call it as map set. Okay, and then the second one is map, and the third word that you need to know is the fields. Map set is defined as collection of maps only. Map is collection of fields here, and a field is the data element that shows, that can be seen on the map, that can seen on the screen actually. Now these fields, guys, these fields that you need to know is there are two types. There are two types of field. One we call it as a label fields. The other one is the data value fields. Label fields are the one only for informative, guys. They are not for interaction purpose. They are just for informative for user. And data fields are the place where we put or we use as input and output of the data. Now, as usually, guys, my English may not be so understandable at first time. Okay, my English, guys, might not be such an understandable language when the first time you hear it. I always tell you with an example here. So I have a screen which is like this login screen, and there is a user ID where you give the ID. And there is a password as well. Now the user ID and the password what I have typed over there, guys, these are your labels. These are your label fields which user can understand what value to type in these fields. The other one that you see, the underscores, guys, okay, the underscores what you are seeing here, these are your data value fields. So when you are designing, guys, actually you will be designing more of the fields only. Collection of all these fields together in a program, we call it as a map. Collection of one or more maps together is a map set, guys. So you will be concentrating more on the fields every day-to-day work. All fields together is a map. So you will be working on the fields, guys, not on the map level. Okay, not on the map level. You will be working more on the fields type only. So you are trying to design a screen. For that, you will be using a BMS mapping support. In like these days, there is not much development in the CSS screens, guys. So we are not using any tools for this screen design. Earlier, like 10 years back, we used to have a tool called SDF, Screen Developing Facility. So where you don't need to write a code, there should be a fill in the blanks. Okay, we'll be having a fill in the blanks. We put the position, we keep the variable name and the field name, and we run it automatically like a deculgen tool, The tool itself will be creating the code. But now we don't have the tools, guys. Anytime they are having any changes in the map, anytime they are creating a new map, guys, they all do the coding on BMS only. So this is the primary thing to learn. Now, I also tell you guys, when you join the project on CSCS, you may not even touch one screen program. Okay, you may not even touch or even you see a screen program for your experience level, but you need to learn these things. Even though I told you in DB2 also the same way, guys, even though you don't create a DB2 table in the project, learning a DB2 table style, learning the DB2 constraints, learning the DB2 data types make you to write good COBOL program. Similarly, understanding the screen design will help you to understand the COBOL program of CICS. So if you don't understand the front-end part, back-end program behavior, back-end program coding part, you will get confused. So first part, understand the design. You don't need to buy hard, guys. Okay, please do not buy hard them. Understand the words, understand what we are trying to design here, and keep a remember of that. That's it. When I come to COBOL CICS program, this information I can use there and I can write a best program for us. Now, I know there is a map to design, there is a map to design and the fields to design. So to design these three things, okay, to design these three components of map set, map and fields, we use some assembler macros. We use some assembler macro. Anytime you hear a word macro, guys, okay, if you are hearing a word macro, it's generally a one word function. It's one word function which already contains the code, which already contains lines of code already. So instead of writing the lines of code, instead of writing 10 or 20 lines of code, you can use only one macro, guys. You can use only one macro there, and that's what we need to learn. So in this BMS, we use three macros. First one is DFH MSD, which stands as map set definition, and this is used to define the map set, component. You have DFH MDI, the second one, which is used to define the map definition. This is map definition interface. That's the full form. Nobody will ask you, guys, don't worry. Okay, nobody will ask you what is the definitions here. Nobody will ask you. So this is define the map, and then DFH MDF here. This is for map definition of fields. Okay, this is for the fields here, and this is to define the fields. Now we need to put them together, guys. We need to put them together and code a BMS program. For this, guys, the code style would be something like this. First, you will be having map set name, then you have DFH MSD, and then you will be having some parameters 1, 2, 3 like this. Within the map set, you can have map name 1 with DFH MDI, and then give the details here. Within a map, you can have a field DFH MDF. Sometimes you can give a field name as well, DFH MDF like this. You can create as many MDFs as you want. Two maps. If you take two different maps, guys, the map set will be same. The map definition will be same. Only the fields, guys, okay, if you take two screens, only the fields will be different to make it as different structure. Okay, to make it as different structure. So once you are done with one map, if you have one more map, which is not so generally, okay, normally we'll have one MSD with one MDI only. We'll not have second map in the same map set. We don't do that. But if at all you want to write, if your project is insisting to write such a way, within a single MSD, you can have multiple MDIs. Once that is done, you're gonna close it with type equal to final. This is like end of the map set. This is the starting. This is the start of the map set, and the below whatever I have written at the last, type equal to final. That is the end of the map set, like a stop run or exit program kind of thing, and end here. This is end of the program itself, end of the assembler program here. You'll have a name, macros, and the parameters. Simple like a JCL only, guys. You have a job statement, exit statement, and lot of DD statements. Okay, for any job, okay, the job statement will be as the same. For any exit, you'll be writing the same syntax. For all the DD statements will change from program to program. Here also only the structure will change on the field level and then you come out of the program. This is your MSD definition or your BMS program, but it's not done. As a developer, guys, as a developer, when you code any program, it could be a COBOL program, it could be a BMS program, guys, you need to compile it. You need to compile it and get the load module of it. This is the code of English. System won't understand this directly. You're going to need to convert it and create a load module of this one as well. Like your COBOL, you need to create a load for the BMS as well. So if you want to compile it, okay, if you want to compile it, there is a job with a program as ASM A90. This is your compiler, BMS code compiler. But this one will do, guys, very interesting one. Okay, very interesting one here. You will be having your input as BMS map set. And when it is compiled here, guys, it will generate two outputs. It will generate two outputs. One of the output we call it as the physical map, guys. One of the output is called physical map. And the second one is symbolic map, guys. Symbolic map here. So there are two maps. Okay, in the interview, they'll ask you this question that's saying that, Anil, what are the types of maps in CICS? One we call it as physical map, one we call it as symbolic map, guys. Physical map is actually a term for load module only. Okay, the way you are in the whichever country you are here, guys, in that language only you have to speak better. Whichever state you are, that language only you have to speak. Till yesterday, when you are in COBOL, guys, you used to call them as load module. But now you are in the assembler compiler, guys. Okay, as per assembler compilation terminology, the load module, we call it as a physical map. Okay, in the interview you can tell load module, in the project you can tell load module, but if someone else is talking about physical map, don't get confused. It is nothing but load module only, the different name, different language. Symbolic map, guys, the interesting part is symbolic map. I'll keep a couple of stars here. The interesting thing here is a symbolic map, guys. Compiling a program and creating a load module is the basic knowledge, basic step. But compiling the program and creating the copybook, guys, of the screen layout, the compiler itself will create the copybook of the screen of your map. The compiler itself will create the copybook itself with the COBOL language. Now, if you remember first step of our copybook, guys, when we started our training on COBOL copybook, I created copybook manually. Then when we came to COBOL DB2 program, guys, we created the copybook using the Deckelgen tool. That means we have changed the way of creating copybook in the DB2. Now, when you come to CICS here, guys, the copybook of the screen is created by the compiler itself. That means the process has advanced a little bit here. So when you code any BMS program, you're going to compile it and get two outputs. One is the physical map, another is a symbolic map. Now you need to know a little bit here. A physical map, which is a load module, guys, which is a load module, is used to execute and see the screen, see the design or see the map on the screen. Whenever you want to show the screen to the user, you need to run this load. Okay, you need to ask the CICS to run this load. When system runs this load, whatever the design you did on this one, that will be reflecting on your screen. That's first point. Second point, what I want to go for symbolic map, guys. Symbolic map is your copybook, which will be used in the program, COBOL CICS screen program here, which will be used for accessing the data input and output. Whatever the data coming from the screen will be stored in this copybook. Whatever the data you want to send to the screen must be sending from here. Like these are your host variables of DB2. Okay, when you have a file, guys, listen carefully. You have created a file layouts in the FD para, and you told that if I want to send the data to this file, I'll be using this layout only. If I read the data off from this file, the data will come to this layout only. We did this one connection in the COBOL for files. When we came to DB2, guys, when we came to DB2, we used the Deckel variables and then we used in our query. And we told that whenever I want to send the data to the table, whenever I'm getting the data from a table, I'll be using the declare variables. Now what I'm telling here is you have a screen, guys. The data is coming from a screen here. For this, you will be having your symbolic variables, which will be used in the CICS commands. That means if CICS want to send the data to the screen, it has to use the symbolic variables. If CICS want to receive the data from the screen, it has to use the symbolic variables only. Now, the beauty of this copybook, guys, okay, the beauty of this copybook, symbolic copybook, guys, it contains two groups. Generally, in any copybook, okay, generally in any copybook, you have seen only one group, one layout. But there are copybooks where we have multiple groups also in that. In this copybook, which is a symbolic copybook, you'll have one group with map name I, which is an input group used only for receiving the data, used only to receive the data, guys. Whenever you want to receive the data, guys, you need to use the input group. The second group in the same copybook will be 01 map name O. Map name O, which is again redefines map name I. Again, how many people remember redefines, guys? How many of you remember redefines? Not the interview question. Okay, in my training, I told you a very special way how to remember redefines. I gave you valid examples. I gave you invalid example as well. So if you remember the redefine point, which I trained, guys, whatever the data is there here is also there in over here. Okay, remember these tags, suffix I for input, O for output. So this is an output group. This is the output group which system will create. And this is only used to send the data to the screen. One you have input group. Okay, one you have the input group, guys. Another will be creating output group. This groups will be created by the compiler only, guys. You are not supposed to create anything here. Automatically it will be creating. If you want to change, you can also change. It's up to you. But better you can use the same itself directly. Okay, let me remind you what I am trying to tell you, guys. We are into online system, and the first thing that you need to learn with me is how to design a screen. You don't need to remember every bit of knowledge what I'm training you, guys. I will tell you which one you have to focus for your interview purpose, which one you need to remember for your project purpose. I'll highlight them as well. But since I'm a trainer, I know a lot of things. I cannot skip them. I need to train you so that it may be useful. Now, when I want to design a screen, I'll be using the BMS coding. I'm not going to use COBOL because I cannot design a screen with a COBOL. I cannot use JCL, which is also not possible. Okay, so we'll be using BMS. In that there are three components to code: map set, map, and fields. Any language, guys, okay, not only BMS, any language if you take. When I started introducing you to the COBOL language, I told you ID division is there, environment is there, data is there, processor division is there. When I started introducing to JCL, I told there is a job statement, exit statement, and DD statement. When we introduced to SQL, guys, we told there is a select queries are there, insert queries are there. So every language has a certain things to remember as a main part, and the whole story runs around that main characters only. For a BMS coding, guys, these are the main characters. If you can understand these characters perfectly, then you can code anything here. So the map set part is the first one, which is a part of your collecting the maps together. Map is the second. Within the map set, you will be having a map which is used to collect the fields, and fields are the one which actually you are showing to the user. Okay, whatever you see on the screen, guys, those are your fields. So these fields, either it could be a label fields, the one which is non-editable basically, and the other one is the data value fields, which are basically editable and non-editable, but it focuses on the data of your project. So when you're designing, guys, you need to use macros because we are using assembler coding here, which runs with a macros. There are three macros: MSD for defining the map set and ending the map set. Within the definition of the map set, okay, this is the starting, this is the ending. Within this, you can write one or more than one maps. For each map, you can have one or more than one fields as well. Once your program is done, here, you're going to go for the compilation, because every program which is written in English language must be converted to system understandable language. So for execution purpose, you're going to need to create the load module, which will be using a compiler called ASM-A90. This fellow is more intelligent. This fellow itself is more intelligent. When you compile the program, it's going to give you the load module and it can generate you the copybook as well, which will be used for showing the screen. Okay, where it is here. This is used to show the screen, and this is used to access the data of the screen. Now, again, developer steps, guys. Developer steps: code, compile, and execute. You did the coding, done. You did the compilation, done. How do I execute?